Let's check out some more examples of determining if two lines in standard form are parallel, perpendicular, or neither. Example 2. Determine if two lines in standard form are parallel, perpendicular, or neither. Take the first equation, 2x minus 3y equals negative 4, and solve for y. So we're going to subtract 2x to both sides of our equation, carry down the negative 3y, which is now going to equal to negative 2x minus 4. Divide every single term with negative 3. And we end with y is equal to 2/3 x plus 4/3. Now that our equation is in the slope-intercept form, this lets us know that our first slope is 2/3 and our first y-intercept is 4/3. Now, let's solve the second equation into the slope-intercept form and see what the slope and y-intercept is. We have 3x plus 2y is equal to negative 6. We're going to subtract 3x to both sides, carry down our 2y, which is equal to negative 3x minus 6. Divide every term by 2. So we end with y is equal to negative 3/2x minus 3. In our second equation, we're going to have our second slope to be negative 3/2 and our second y-intercept to be negative 3. Let's review what we just did. In our first step, we want to convert both equations into the slope-intercept form. When we solved the first equation into slope-intercept form, we found out that our slope was 2/3. Then we put the second equation into slope-intercept form and found out that this second equation, m2, is equal to negative 3/2. Taking this information, we now have our two slopes, m1 equaling 2/3 and m2 equaling negative 3/2. In step 2, we're going to check if their slopes are negative reciprocal. To be perpendicular, the slopes must satisfy the condition, the slope 1 times slope 2 is equal to negative 1. So we can check that 2/3 times negative 3/2 does equal to 1. In conclusion, these two lines are perpendicular because their slopes are negative reciprocal each other. The first slope is equal to 2/3 and the second slope is equal to negative 3/2. So these two graphs are perpendicular and they'll look something like this. Here's our third example. We still want to determine if the two lines given to us are parallel, perpendicular, or neither. We're going to follow our first step again by taking our equation and rewriting it into the slope-intercept form y equals mx plus b, so we can figure out what the slope is and what the y-intercept is, if necessary. So we have our first equation, which is 2x plus 3y equals to 6. We're going to subtract 2x to both sides, then bring down our 3y, and that's going to equal to negative 2x plus 6. Divide every single term by 3 so we can isolate the y. So y is now equal to negative 2/3x plus 2. So now we know for our first equation, our first slope is negative 2/3 and our first y-intercept is just 2. Now let's take a look at the second equation. Our second equation is x minus 4y is equal to 8. We're going to subtract x to both sides, carry down our negative 4y, and that's going to equal x plus 8. Then again, divide all terms by negative 4 to isolate the y. Now our y is equal to 1/4 x minus 2. So in our second equation, our second slope is positive 1/4 and our second y-intercept is negative 2. Okay, let's review what we just did. In our first step, we want to convert both equations into slope-intercept form. We found that the first slope is m1 equaling negative 2/3. And in our second equation, we found that the second slope is m2, which is equals to 1/4. Now that we have our equations in slope-intercept form and we know what the slopes are of each of them, we want to move on to the second step, and is to compare the slope. Since both the slopes are not equal to each other, we know that they are not parallel, and they are not negative reciprocal of each other, meaning their product does not equal to -1. They are also not perpendicular. We don't need to check their y-intercepts because we already know that they're not parallel. So in conclusion, these two equations are neither parallel nor perpendicular because their slopes are not equal to each other, nor are they negative reciprocal of each other. So in this case, this is a neither case. So both of the graphs are neither parallel nor perpendicular. So what ends up happening is that we have just two lines that intersect each other at a given point, but not at a 90-degree angle. And that's it. These are our examples of solving standard equations to determine if they're parallel, perpendicular, or neither. If you found these videos helpful, consider liking and subscribing. It'll help me out a whole bunch. But otherwise, time to get out of here.